Good evening, everybody. We'll make a start. I'm Peter Craftle. I'm Professor of Human Geography and also the Deputy Head of College for Life and Environmental Sciences. I knew that as soon as I started speaking that someone would come through the door. Always happens, doesn't it? A very warm welcome to everyone this evening, with a special mention to Tricia and Steve, Julia's parents, and to Chris, her husband. Yeah, we've got a slot to find for that purpose. I'd also like to extend a warm welcome to everybody else, whether you're from the School of Biosciences or from elsewhere across the university. And if you haven't already, just a note to sign the message of congratulations that's at the front there. It will remain there until after today's lecture. So just a few notes from me about Julia and about your journey here. So Julia's journey in animal behaviour research began during her undergraduate degree in applied biology at the University of Bath. There she completed her final year project at Bristol Zoo, studying Javan langurs and black howler monkeys, whilst also volunteering at Twycross Zoo and participating in conservation work in South Africa. After graduating, Julia moved to Lancaster University, working as a research assistant in the insect ecology group. However, she soon realised that lab-based work wasn't her passion. She found her true calling with a PhD opportunity here at the University of Birmingham, joining Susannah Thorpe's group in the School of Biosciences, studying locomotion and behavioural ecology in orangutans. Over 4 years, Julia explored both the anatomy and behaviour of these beautiful animals, with time spent on Sumatra in Indonesia and in Jena in Germany. Following her PhD, Julia took on a postdoctoral position at the Royal Veterinary College in the Structure and Motion Lab. Here her research took her to Botswana, where she studied the cooperative hunting behaviour of African wild dogs, but also to Norfolk to study sheep and even people. But the call of Birmingham was, of course, strong, and in 2012 Julia returned to the university as an education-focused lecturer in biosciences. Over the past 12 years, Julia's held numerous roles within the university. This has included key positions in the Liberal Arts and Natural Sciences team, Head of Education in Biosciences, and most recently, Director of Sustainability Education. During this time, Julia has organised and spoken at national and international workshops and conferences, all centred around collaborative and interdisciplinary education, two areas that she's deeply passionate about. She secured funding to develop innovative ways of making education a more collaborative process, engaging students in co-creation and founding communities of practice, and is currently working with colleagues in the US to foster global partnerships to address sustainability challenges. Some other achievements during this time include her two children, Amelia and Madeline, with Madeline arriving a week before the first lockdown, meaning that she missed the year where everyone battled to adapt to a rapidly changing situation, online teaching, returning to a very different landscape in 2021. Beyond her contributions at Birmingham, Julia's been actively involved with the Association for the Study of Animal Behaviours Education Group since 2016 and served as a council member and education secretary since 2021. She worked as an external advisor during the establishment of the London Interdisciplinary School in 2018, which was the first new institution to be granted degree awarding powers since the 1960s. Julia also helped to shape the development of the new Society for Natural Sciences and their degree accreditation process in 2019. The combination of these activities has led to Julia's role in sustainability education, a space which brings together her research interests and knowledge of how animals adapt to their changing environments, but also her passion for interdisciplinary, challenge-led education. So please join me in welcoming Julia to give her inaugural lecture, From Wild Dogs to Wild Ideas, The Power of Collaboration.
Thank you, Peter. That's wonderful. I feel like I'm done now. No? start this is with a list of words. Now, these words will be very familiar to a lot of you, particularly those in liberal arts and natural sciences, but I was really looking for a way to actually bring all of the different things I've done together. And it wasn't a particular theme or topic or branch of research. It was more of a set of ideas and approaches and ways of thinking. And these are curiosity, openness, flexibility, balance, collaboration, and adaptability. So how I'm going to frame today is we're going to go through these and dip in and out based on whether it's education or my research and how it links with some of those words. I also appreciate, though, that people do sometimes like a timeline. So Peter's already done a lot of that, so I'm not going to talk through it all, but you've got a sense of where I come from was a fairly biology background, if you look from my undergrad. But actually, when I started looking back, you can already see from even school, I was trying to push those disciplinary boundaries. And this may be in a simple way, in the sense that I did both geography and history at GCSE. Now, at school, that is not allowed. You can only do one of geography, history, and RS. And I made them bend the timetable and flex and create a different group so that I could do both subjects. And actually, I think that's kind of set the foundation moving forwards. My A-levels were very traditional. In hindsight, I would rather have done biology, history, and actually geography. So ignore the physics and chemistry. They were an interesting choice, but needed to do biology back in the day. I'll touch on a lot of this as we go through. Since I've come to Birmingham, though, as Peter already alluded to, I've had a number of roles, and I think I've got a bit of a reputation for dipping in and out of things and being always in a bit of a split role across different departments, working with different people. And actually, it's fantastic to see loads of people from those different spaces here today. And I think that's what I found most fun about being at Birmingham. I work with people from across the different colleges. Now, I will get shouted at, but I have to mention Chris. He's always a bit like, where do I feature? Because I always mention the girls. Sounds really bad.
Disappointing you for a lift photo instead.
Yeah, no. So Chris and I have been together since school, so he has been beside my side throughout that entire journey, including a year on Sumatra, where I saw him for 2 weeks the entire year. And then came home and probably went back to Germany for 3 months. And then got a postdoc where I went, sorry, I'm off to Botswana for 4 months. So he has stuck with me through all of that. We're going to mention the girls. They can't be here today because they only got home from school. Emmy would have loved to have been here. But these are a key part of this journey as well, and they make you think about what you're doing and how you're adapting. So I had to put those in. Right. Let's go on to curiosity. I'm not going to spend long here because I'm hoping that this is something that everybody has, but I know people like childhood photos to start with. So my mum managed to find this one of me with a macaque, which I had completely forgotten that I'd even seen. But clearly my love of primates started young. But curiosity is the desire to learn or know more about something. It's just that innate interest. And I always start my lectures with students about this. Because hopefully that's what they're at university for. We want to enable them to foster this passion to just be curious. And I always love the quote, I have no special talent, I am only passionately curious. And actually I think that's quite apt. It's continued to today, and I'm not going to lie, so I've worked on sheep. This is not one of the sheep I worked on, but I do feel this is my kindred spirit in the hair department. Not today, but normally. So I'm going to jump from curiosity and go straight to openness. And it was really interesting pulling this together because it suddenly made me reflect on people that have shaped my journey and had more of an impact than I think I ever realised at the time. And I think, particularly as educators, those in the room that teach, this is something to bear in mind. So Alan was my tutor all through my undergraduate, and Matthew was my undergraduate project supervisor. And it's only in hindsight that I really appreciate the fact that they didn't necessarily fit within their departments. They weren't classical biologists by any stretch of the imagination. So Alan was a fungal biologist, but also a philosopher. He wrote poetry, And he encouraged us to do artwork. That was one of my final year pieces. Thank you, Dad, for helping paint a tree. The concept was all mine. The art gene maybe skipped me a tad. But Alan really encouraged us as undergraduates to think outside the box, take different approaches. And I actually reached out to him before this just to touch base and say thank you. And he said, do you realise how hard it was to run that module? So this was in 2005. And he said he had to fight and fight and fight to be allowed to run a module that was that interdisciplinary and open. And it's only in hindsight you go, thank goodness people like him did that then, because actually look how much easier it is now to be able to do that. And then Matthew was actually a paleontologist in the biosciences department. And again, he was the one who let me go to the zoo when I said I really want to do this type of project. And he supported me with that, and also with coding and different things that we weren't normally exposed to back then, which now seem quite common. But this was my artwork, which I think, again, really reflects where I've come to today. And the whole point was, I called it the whole picture. And it was the fact that in science, we don't want to just abstract and take something out. We have to consider everything it's come from and how it all interconnects and is linked. Today, and more recently, I think openness has really helped me kind of shape my career and certain things I've been involved with. Two things. One was when a friend said, let's do something crazy at an open day, and we ran an experiment with all the students at the Royal Veterinary College and got them to count sweets. But that actually led to a paper, and that's about wisdom of the crowd. I'm not going to talk about wisdom of the crowd today. If you want to know more about that, we can talk about that. But then I bought that, and we actually used to do that in open days here as well. Perhaps my openness was most challenged, though, when I went to a British Animal Studies Network meeting. You may think, well, animal studies is what you do, but the Animal Studies Network is actually based in the arts and humanities. And I was one of only 2 people from a science background at the entire 2-day conference. I was the only person to have PowerPoint slides and to stand up and present. And the whole thing felt really bizarre and uncomfortable to me. But also, how fantastic, because I got to hear new things, see different approaches, and find out how people in different disciplines do things. And that was a really good eye-opening one for me. In particular, it made me realise how much we can support each other across the disciplinary boundaries, even in a research sense. And now I'm going to jump to flexibility, and we're going to spend a while, I'm not going to lie, on flexibility and balance. So, let's first of all go to the forest. Now, you can also tell how long ago this is by the quality of the video footage, I'm not going to lie. And the camera person is maybe questionable. This is Yasmin, is Susannah on the air. That's the mum who's the air. This is Yasmin, who is 8 years old at the time. So the camera I just wanted to get a sense of how they are, how they move, how much have we got the hands in that the distance really is growing, so they can actually tackle the very big things. And they're going to make their way down in seconds. And they talk about an hour to travel down after them. It just gives you a sense of how they move through the forest. And I'm talking about how they move there's another great video later. But what I really wanted to see here is just how
why no? Yeah.
So, flexibility and plasticity, I've called this. And this is a story of both mussels, branches, and orangutans. And this was my PhD here with Susannah. So thank you, Susannah, because it was the best, the only PhD I wanted to apply to. So thank goodness I got it. The title ended up being Applying an Ecomorphological Framework to the Study of Orangutan Positional Behaviour and the Morphological Variation within Non-Human Apes. If anyone has seen the kind of titles I give to modules, no one will be surprised by that. What do we mean? Fundamentally, we were interested in how the morphology or the anatomy influences their form, influences what they can do, i.e. their function, but in particular how the ecology plays into that, so the environment that they're moving around in and how that impacts on all of these different stages. The main focus was orangutans, but we also then compared to the other non-human great apes. So the other non-human great apes, we have chimps. Most people know about chimpanzees. They are very different. They are large group-living animals. They live in large groups to 150. Most importantly, in terms of how they move, they will often travel on the ground. Anyone who's seen David Attenborough documentaries will see them travelling on the ground using quadrupedal motion, so walking on all fours. That's very different to orangutans. We then have gorillas, the largest of the non-human great apes. They're beautiful, very majestic. They live in smaller groups, so normally you have your adult males, sub-adult males, and maybe a few females and their offspring. They are more arboreal, so they live in the trees more than you might imagine, but they often travel there to feed rather than move through the forest in the trees. Then we have bonobos. A lot of people don't realise bonobos exist, or they tend to conflate them with chimpanzees. So a clear way to tell the difference is they often have a hair parting. They have quite a funky hairstyle, but they're much more what we call gracile. So they're more slender, more delicate looking than chimpanzees. But live in a similar way, apart from these ones. Chimpanzees have usually an alpha male and a male-dominated society. Bonobos are the female-dominated society. So very different from that perspective. Then we have the best. I shouldn't say that, but we do. We have orangutans. And orangutans are quite different in that they're often considered solitary. They're not completely solitary, but they do tend to live more on their own. So you'll have a male, and then you'll have females who live with their offspring up until 8 or 9 years old. So orangutans have the largest interbirth interval of any mammal. They only have one offspring every 8 to 9 years, which is one of the reasons they're so endangered when you think of their turnover. This is a female with her offspring. And then obviously the males are quite famous because they're much, much larger. So an average male is around 86 kilo, whereas a female is around 38 kilo. So there's a huge size difference there. And that's really important when we're thinking about how they use the forest and how they move around in that environment. So that's just some background context. Now, one of the first things we were interested in was their muscles and their anatomical adaptations. I've just said there that they do tend to use their environment slightly differently. I realised I didn't say about orangutans. Orangutans barely ever come down to the ground. They stay all the time in the trees, particularly on Sumatra because of tigers. So they have to adapt and move through the trees. They need to be able to use both the thinnest supports and the thick supports to move around, which is quite different to some of the other non-human great apes. So we were interested, do we see that difference in locomotion play through to their anatomy? Do they have muscles that are different in terms of where they insert or where they originate from? Do we see differences in some of the actual properties of the muscles? So the way to ask that question is, of course, to study them, to do dissection. If you want to do dissection, we do not go into the forest and kill them. I did once get asked that in a lecture by a student. So I am going to emphasise the fact that we only dissect ones that die naturally in zoos. So of course they're captive. Where do you get your sample of non-human great apes? Well, this is Andrew Kitchener. You may have probably knows him. He's very famous in the anatomical world. He basically has dibs on everything that dies in a zoo in the UK. He is based at the the Natural History Museum of Scotland, so he's up in Edinburgh. This is also why they have one of the best collections of taxidermy animals. He literally has his hands on everything. So we could ask Andrew. Things are in various freezers. Liverpool had quite an interesting stock of things in its freezers, so we worked closely with Robin Compton at Liverpool, and I once went to help clear out his freezers. Wow, that was an experience. There were things like polar bear feet coming out. There was a lemur that I think he said he brought back from a long time ago. It's interesting what's in freezers. But one thing But that happened once, though, while I was doing this, is sadly Twycross Zoo lost 2 of its gorillas quite close together, sub-adult males. Well, it made no sense whatsoever to get them shipped up to Edinburgh when we were here and we wanted to dissect them. But then you think, well, how on earth do you get said gorilla from the zoo to us? Enter my dad. Not with the influence that he's got there, I would like to say. He did not kill the gorilla. But remember, this is back in 2007, 6, 7. So enter my dad, his estate, and some pond liner. And we went to Twycross. We removed said chimp from its chest freezer where it had been wedged. It was 152 kilos. This is an enormous thing. And we slid it into the back of the estate and drove down the motorway and brought it here. And then made a dissection table using pond liner. All health and safety things were considered. What did we find, though? I should actually do some science there. Interestingly, so this was my sample, which actually is still probably one of the biggest samples of dissection and anatomy in the non-human great apes that still exists. Because some of this was from individuals that were found or located in people's freezers that died quite a few years ago. Some had died at the time, but it's still a pretty big sample. What you will see, though, is, of course, it's actually quite a biased sample. We have a lot of males and only a few females in our orangutan. So I should say Pongo abeli is orangutan. We've got gorillas here, chimpanzees are Pan-troglodytes, and then bonobos, Pan-paniscus. But we had some, and we had multiple of every one, which is pretty impressive. You can see the range in body mass, though, and that's partly because of the age range as well. So we had some quite young juveniles in terms of the orangutans, up to 175 was our largest gorilla. And believe you me, I mean, Susannah, I don't know, some of these dissections where you're humping arms and bodies over, it's just you and me, and this 175 kilo gorilla that you're trying to like manipulate. I haven't got any photos of that. But what we found is that when you scale for body mass, so you always scale for the actual body mass, we actually found very little difference in terms of what muscles were present or absent, and they're incredibly similar to humans. We often use human dissection books. Very little difference in something which is called physiological cross-sectional area, which is basically we use this as a proxy for force production in the muscles, and then also in muscle fibre length. So that's the length of the muscle fibres that run through a belly of a muscle, and they tell you about the speed with which a muscle can contract and also the range of motion over which it can contract. But very little species difference. What we did find, though, and I've just extracted one of the graphs here, is you can see some of the enormous individual variation. So even within the gorillas, in the black lines, the individual variation, this is the PCSA, so force production of this one particular group of muscles, was enormous. And that's really interesting. But that also does play through when you look at human dissection. You'd be amazed by how many differences there are in terms of the muscles you have or where they insert sometimes, even between humans. Equally, so we're saying there's not much difference. Well, that's probably because they all do need to move through an arboreal habitat at some point. They may not do it the same frequency, they may not do it in exactly the same way, but they are all using a lot of those similar behaviours, particularly one which we call orthograde scramble, which is where the body's upright and they're using the limbs in multiple ways. They all do that. So maybe that's what we're seeing in the muscles, that actually they're all adapted for those very similar behaviours, but they're using in different frequencies. Equally, it may be that the magnitude of the difference may not need to be that great to have a functional impact. So we don't always know what's playing on in that relationship. So we didn't find a massive amount of difference in what we call the gross muscle anatomy. So we asked, would you see a difference in the actual muscle fibre types themselves? So within a muscle, you will see the lines of muscle fibres running through the belly of a muscle when you look at it. Each one of those lines is a bundle of fibres, and then Within a fibre, you get different fibre types. This is what it looks like when you slice through it and you stain them. Being very simple here, you can have fast fibres, slow fibres, and intermediate fibres. It's far more complex than that, but that's where we're going to leave it for today. In this one, this is actually just staining fast and slow. So the slow fibres are blue, the fast fibres are the brown. And most muscles will have a mix of these fibres through the muscle belly. They may have more of one type overall or more of one type in a certain part of the muscle. And that will be related to its functional use. So we wanted to know, does this differ? Because muscle fibre typing, or muscle fibre types, are really plastic. If you injure yourself and have to rest up for a few weeks, you might even then start to see changes in your muscle fibres. So they're really plastic and adaptable. So this is the work that I actually did in Germany, in Jena, with Nadia Schilling. And we decided to look, you can't do this across all the muscles, or you could, but you'd have to take a very long time. So we focused in on the triceps surae muscle group, which is the back of your calf. You have closest to the bone, the soleus muscle, which is the big one that runs down the back. And then on top, you have the gastrocnemius muscle, which has two heads, the medial and the lateral head. And these muscles in us, so this is a human leg, insert on our very long, nice elastic, springy Achilles tendon. The apes do not have a long, springy Achilles tendon. And that's a really important human adaptation. That's for us to run. That stores energy so that we can run and bounce off that. Great apes have a very short, stubby Achilles tendon, which gives them much more control over where they're putting the force from their muscles and how they're controlling the muscles. But we focused on that muscle group. This took about 3 months. We had one female orangutan, one female chimpanzee, and one male chimpanzee. And we dissected out those muscles, sectioned them, and then also cut them into sections, and then took photos of each of the sections in multiple ways. So this just shows you how many photos to go through one section. And then, because AI didn't really exist back then, I went through and counted by hand all the fibres in every single photo. Bearing in mind, this is just one muscle, and we did this for 3 different samples and 2 heads of the gastrocnemius muscle, which was also so big it had to be cut into 2. I spent a lot of time clicking on fibres to count them. But what did we find? Because that's the most interesting bit. We found that orangutans overall had far more slow fibres than chimpanzees. Probably not a surprise. Orangutans are very slow, careful movers in the forest. They don't move particularly at high speed. So they would need more slow fibres to allow them to do those slow, careful movements. The chimps, interestingly, have more fast fibres in their soleus muscle compared to most other mammals. So the soleus muscle is often seen as what we call a postural muscle. It's the muscle that is always activated when we're standing. It enables us to stand, it has a lot of slow fibres. That's generally its use. But in chimpanzees, it seems to have more fast fibres. Now, one of the reasons for that may be that I've already mentioned they don't have much of an Achilles tendon. They have a short Achilles tendon, which we use for running. But chimpanzees do need to do fast movements sometimes when they're terrestrial. They do it for sexual displays, they do it to be aggressive, to charge at one another. So perhaps one way they get around only having a small Achilles tendon is by having more fast fibres there to enable them to do those fast propulsive movements. And that is all about compromise. They don't want a big Achilles tendon because that would compromise their ability to move through the trees in the arboreal environment. The orangutan, on the other hand, seemed to have a particular distribution of fast fibres in the soleus muscle. It was mostly slow, but towards the insertion with the Achilles tendon, there were a lot of fast fibres. And we think that that might be to do with these. If you look at the orangutan here, you think, I know this is in a zoo, so this is a rope, but if they're on a branch, if they're stepping on something and it suddenly moves, they need to rebalance and correct themselves really quickly. By having fast fibres inserting near the Achilles tendon, they can direct those fast propulsive movements that they need, small ones, directly down where it's needed. All of this, of course, is based on a sample size of 3. So, we take it all with a pinch of salt, but again, these studies are really hard to do, and they don't often get repeated. but they're showing potentially interesting insights into how these animals are adapted to this environment. Now I'm going to jump to flexibility in education. See what I'm doing with the word stuff? One thing employers are constantly telling us is that they need a workforce that is adaptable, quick to respond to change, able to cope in dynamic environments, and that's often through collaboration and continuous improvement. So to me, that often sounds like the animals I'm studying. And that's what I find really interesting. And recently I've been using the word agile more, and with students saying, you are going to need to be agile in how you approach the workforce and move around. And one of the ways we've done this here in terms of an education context is through RAMS, and Betsy may forgive me, may never forgive me, for developing an MRes in interdisciplinary study where students can basically do what on earth they like, as long as they can find a supervisor, and the question is interdisciplinary in some way. And then, as part of that MRes, we created a module called the Open Skills Box, which is essentially a shell where students fill it with things they know they want to learn. Things that will support them in terms of their project. If they say, I need some coding skills, we would support them to find an online course or a workshop that's running here. They can put different amounts of different bits in that space. And then they pull together a portfolio which shows us how they are taking their learning and using it to grow and develop. So it's that concept of lifelong learning, which we talk about a lot. We would all probably like more time to do, but this actually enables students to do that, but in a safe space, where they've got a tutor to guide them through that. I'm not sure, Betsy, if any students have actually jumped on board and done that yet. We're on the second cohort of MRes, which I then promptly created and abandoned. So that's why I'm saying thank you, Betsy, because she has took on that challenge. But it's working really well, and it's giving students a space where they can study and ask those questions which aren't there in a more standard master's programme. So that's one of the ways of being flexible. I have no idea what time it is. Right, okay. I've done flexibility. I'm going to have a bit of a look at balance, which comes back to orangutans again, but now I'm going to go into the field with orangutans. So, as part of my PhD, I spent a year here at the Tambo Research Station, and here is about here. So this is the Gununglusa National Park, and we're about here, which is a 8-hour drive to Medan, the nearest big city, and was about a 1-hour drive to any internet, but I should just be happy that there was internet. This is what primary rainforest looks like. So this is how complex parts of that environment can be. And here you've got, of course, the beautiful as well, the classic lianas, which just weave their way through the forest. But of course, if you're an animal moving through that environment, you have no idea how that's going to respond under your body weight. Is it going to completely give way? Is it going to hold your weight? You need to make sure, and this is what orangutans do really well, that they have multiple points of contact at all times on different branches. Because should something break, you don't want to fall. These are just some photos, I know everyone likes photos. Note the leech socks, essential piece of kit. And they used to come at you along the floor. If you sat down, they can sense you're there. For anyone that doesn't like them. I was the only person that spoke English, and I spoke very bad Indonesian and only started learning when I got there, for 7 months. It was, as Susannah always said it was going to be, 80% really hard, 20% phenomenal. And if it's that phenomenal bit, makes it worthwhile, and it really did. Because they really are the most amazing animal to spend your time with. And boy, do you spend time with them. When you're working with orangutans, what you need to do is you get up normally at about 4 o'clock in the morning. You are in pitch black, hence the head torch. You walk through the forest to where you know they nested the night before. You then will follow them through the forest wherever they go, be that uphill, downhill. Yeah, they like to do that a lot. For 12 hours, recording your data all the time. You then record where they nest, and then you walk back to camp. And you do that for 4 days at a time, and then you give them a rest. You give them a rest, you have a rest, and then you'll go searching for your next orangutan. And you do that in cycle, basically, for 12 months. So field work in the rainforest is tough, but amazing. I mean, the animals you see and the bugs. So I mentioned the insect ecology group earlier. I do have a space in my heart for insects. The things you see are just phenomenal. And you're thinking, is this something anyone's ever seen before? I mean, this thing here. I mean, the nose on that. So this is its eye. These are the wings of this insect. And then this is its nose with a bright yellow shiny tip. Isn't biology fabulous? That's what I just love. So also, I'm now sad that this was so long ago that the quality of the camera was so bad. I think it was something like 6 megapixels for an SLR. Now we laugh at that, considering what's in our phones. But what was I doing there? Let's focus on the science. We were really interested in, so Susannah had been there about 10 years before, and really collected one of the first most comprehensive data sets on how orangutans move through the forest. By the way, these images, I pulled these straight from like a PhD presentation, back in the day when you used to make them in PowerPoint, and they were very limited, but I quite liked them. So we had a really comprehensive data set on all the different movements, all the different, what we call postures, so positional behaviour is posture and locomotion of orangutans. But we wanted to ask some more detailed questions. So it was becoming particularly apparent that orangutans probably have a particular skill set to cross gaps, and they do this often using something called sway, so where they sway a tree backwards and forwards, like a child on a swing, to cross a gap, so they understand the flexibility or compliance of the tree. But also they often access what we call the terminal branch niche here, which is where the best food is, but also, of course, the smallest, thinnest branches. So we were really interested in how they are doing those behaviours. So one task I had was to try and film, using a high-speed camera, every time they did this behaviour, so pumping the tree backwards and forwards, and also bipedalism. I'm not going to go down that route today, but that's what we were trying to do. Bearing in mind this was 2007, this was the camera that could do 100 frames a second, which now you have, it's in your phone. This was about this big, and I had it on a tripod, and I used to carry it like this. Through the lianas and the paths, and if as soon as you saw an orangutan, you might be going to pump it, it was like, right, tripod out, get it all set up, and try and film it, because you needed to be perpendicular to actually get any data from it as well. It was challenging. We knew that was going to be challenging. I think we ended up with 10 videos of sway and about 8 videos of bipedalism in 12 months. So, as people know, you always have a backup data set. The backup data set for me was recorded by hand, not video camera, and it was using dance notation. And again, this is where you reflect back and you go, oh, I was doing weird interdisciplinary stuff way before I realised what I was doing. And this is because Robin Brompton said, oh, lab notation is a method that you could maybe look into, which is this one here, by the way, which is where every movement has a symbol. You can do entire masters in this to record dance. I didn't have time to do that. So what I did use was something called Sutton movement writing, and adapt it to orangutans, which is much more based on essentially drawing stick figures. As someone that had danced for most of their life, this was really, I was just really passionate about this, and I was like, yeah, let's do this, let's go with this crazy idea. So, no, wrong way. We used this method to record orangutan's posture every minute during those days. So I wrote it down in the notebook, and everything had a code, and there were meanings, and you wrote what branch sizes, what angle. I was interested in how they use it during feeding, so what were they feeding on, where is it located, what feeding method, what tree zone. And we recorded that every minute for those 12 months. Now you may think, wow, what a data set. I actually worked it out earlier. It should have been, if you're following them roughly for 100 days over the year, let's say, 720,000 data points. How many do you think I got? 4,440. It's incredibly hard to see them when they're in the forest. Even you're following them all day, but getting a clear line of sight to record data for a minute is really hard. I was thrilled if I used to get 50 data points in a day, bearing in mind you're following them for 12 hours. But that data set was really interesting, and it enabled us to look at how they use different postures to access particularly those outer branches of the trees, the really thin ones. Are they doing something special there? Now, the other non-human great apes often use something called orthograde forelimb suspend, which you can see here. Orangutans do it too, which is essentially where you hang from one arm and you feed with the other one. Pretty risky behaviour though, because all your body weight is hanging on that one arm. Do orangutans do something different? Yes, they do. They actually most commonly use forelimb hindlimb suspend, which is this one. This is just to show you the body posture. Bad example, orangutan, if that branch breaks, you're going down. They will often do that with their limbs on different branches. So it enables them to spread the weight. And then they also do something really funky, which orangutans do a lot, is this orthograde quadrimanus suspend, where they will have their legs up, so they're suspending from their legs as well as an arm, and then use the other arm to reach for food. So they do appear to be using different postures to what we tend to see in the other non-human great apes. So they've clearly got greater adaptations to that arboreal environment that they're really adapted to. Balance, now coming on to what I'm doing these days, is something that I'm particularly passionate about in terms of sustainability and sustainability education. The Sustainable Development Goals are something that we're all striving towards. How they're presented often is just like this. A set of boxes, which people often think I'm going to tick them. And I'm going to say I'm doing that one, and that one. I even read something today which says, tick which 3 your university is aiming towards. And I'm like, we're not aiming towards 3. We should be aiming towards all of them. And so I'm really keen that we start to look at how we balance the different SDGs and pull together the different approaches. And in particular, I tend to advocate for the bigger, broader model of the 3 pillars of sustainability, which is environmental, economical, and social. Considering the balance between all 3 areas is where sustainability meets in the middle. You shouldn't just be focusing on one or the other. This is another model which is often now used for the SDGs, which, while it tends to look a little bit more at the relationships between some of them, I think is still really dangerous because, yes, it's saying that the biosphere and the planetary boundaries are the foundation. Equally, it could make you think that the economy is at the pinnacle, which I think is a really dangerous model. So balance fits in here in that I think we need to be really careful in terms of how we approach and tackle sustainability in the SDGs, and particularly how we think about it when we're teaching. Right, everyone's going to want wine. Collaboration. We're on the last research bit. Collaboration for me really fits into my postdoc, which was really catchily entitled Cooperative Aerodynamics and Radio-Based Dynamic Animal Localization. CARDL was the acronym. I mean, we think Birmingham likes acronyms, but this was the Royal Vet College, and I was like, I'm going to work on a project called CARDL. No one could even say it, like Cardile? CARDL. Nobody could remember it. This was probably the biggest, actually supposed to be interdisciplinary project that I've ever worked on. So there were a range of animals. There were sheep, we had ibis, pigeons, originally domestic dogs and African wild dogs, lions, leopards, cheetah, and people. It was a joint project between the Royal Vet College, which was Alan Wilson's half, and then Steve Hales at UCL, he's a computer scientist, and they brought 4 postdocs together. 2 animal biologists, one was myself, the other was Steve Portugal, who I totally poached from Birmingham and dragged with me to the Royal Vet College, an engineer and a computer scientist. And this was that classic early days of interdisciplinary research projects where you put these people in a room and magic will happen. Magic did not happen. We could not talk to one another. It was just ridiculous. I mean, I was the one working on the mammals, Steve was working on birds. We got on like a house on fire. We'd known each other for years. Trying to then work with a computer scientist to get the machine learning aspect right and for them to understand that, well, sheep might not do that. Why? Well, because they're an animal and might do something completely different. It was so challenging. And in hindsight, I realised it's because nobody had sat down and said to us, you are working, nobody even used the word interdisciplinary, on an interdisciplinary research project. There are certain skills you will need to be able to work in that way. And this is now some work that myself and Simon did when we first started back in LAMS in like 2016-17, looking at the skills to be interdisciplinary and thinking about how we start educating people in that space. So clearly it's often not just about working with different disciplines for the sake of it, they need to be complementary. Now in that project, they were really complementary, but nobody kind of pointed out directly to us how they were going to be complementary. Importantly as well, it's not always just about subject knowledge with interdisciplinarity. It's about the methods as well. Maybe taking a method from one area and applying it to a new area. And this is something that myself and Simon looked at a lot and is now something I still do in my modules, and I know the LAMS team are still building even more and more, how those students learn to be interdisciplinary. The magic will not happen if you're not taught the skills to do it. And these are potentially, I think, the most important ones. Being curious, again, is up there. Respect and openness, so respect for the other disciplines. No more, oh, my discipline's better than yours. We can't have that, there's no such thing. Patience, though. Patience to learn how to communicate with one another and which space you can occupy together, and diligence to do that. The ability to reflect on yourself and your own biases in terms of how you approach things. And then again, that flexibility to go, that's actually a really cool idea, let's try that. Oh, that hasn't worked, let's try something else. And I think the most important thing to take away from this is that it's not about just expecting that these skills happen. It's about encouraging students and also people in research teams to consciously engage with those skills and to actually think about it as part of the process and a skill set. Now back to Botswana. I jumped around. I warned I was going to do that. Botswana was fabulous in the sense that it is like a holiday. I'm not going to lie. If anyone says, I mean, field work in a primary rainforest is tough. Field work here was, you do about 4 hours of field work a day, because the animals don't do anything in the middle of the day. They've all got collars, so you know where they are, and you go out in a car. So it's kind of like holiday. I was there for about 4 months. Occasionally we stayed out overnight, so that was quite exciting. But generally we lived in these nice posh tents. It was a very nice camp. I worked with the Botswana Vegetable Conservation Trust, so really good group of guys to work with. We had cheetah, lion, African wild dog, and leopard that we were working with here. So it was kind of hitting multiple areas in terms of collaring them. Again, fabulous animals, bigger ones, more than Indonesia. Tends to be the big ones that you find here, but just another excuse to put some nice photos in. My camera was slightly better by this point. But just got to see some amazing things. So being a field biologist is super cool. What we were interested in particularly though was about cooperation. And in particular, we were looking at the kind of actual functional locomotion of some of these species. Well, my focus in particular was asking the question, do African wild dogs actually cooperate? Do they work as a team? Because that is something that is constantly perpetuated through kind of wildlife documentaries. When people ask, do they hunt cooperatively? People are like, yeah, of course they do, they work in a team. Well, this is actually what it means to work in a team or a group, something important to take away for students, I often think, with group work. When we talk about group work, we don't actually want them necessarily to do group work, we want them to do teamwork. Because a group task, is something that requires multiple individuals to perform the same activity concurrently, whereas a team task requires different subtasks to be performed concurrently. And that's really important when it comes to cooperation, because in terms of hunting, cooperation fundamentally means doing a task together to achieve the same end goal. That's very simplifying it here. When it comes to hunting, what we do is we then say there are different levels of cooperation. And these are the levels. But people will often jump straight to this one, collaboration, where hunters perform different but complementary actions directed towards the same prey. So these are the ones where you might have, for example, people say, well, you've got lions lying in wait, and then others ambushing them so the prey run into those ones lying in wait. That's collaboration. And that's often what people are talking about when they say cooperative hunting, rather than appreciating that actually it has all these different levels of complexity. People had always said African wild dogs hunt cooperatively, often meaning collaboratively, and that was based on a lot of data taken in the 90s from Tanzania and places where there's much more open grassland. It was taken from people viewing them from vehicles and being able to see them at quite a large distance. Now, African wild dogs live in packs. They have a dominant male and female pair. You then have some what are called subordinates, who are normally 2 to 3 years old. You then have 1-year-old ones and pups. So packs range from anything from like 6 to 20 plus dogs. But we wanted to ask, do they hunt cooperatively? Can we actually answer this question? So to do that, engineers, I say we, I do this thing, developed collars, which now you can buy off the shelf. This is where it's just changed so dramatically. They were designed with GPS that can go up to 5 times a second when the dogs are running. They were solar powered, sustainability, as well as batteries. They had accelerometers in there which record body acceleration, so whether you're going up, down, left, right, forwards, backwards, and we use that to see what behaviour they're doing. And we were able to put collars on one pack of 6 dogs. So all the dogs in this pack had a collar. So we would be able to see exactly where all the dogs were at any point during the hunt. Brilliant. So we can get the position of all the dogs, the timings, what they're doing. We can get the habitat because of Google Earth. We couldn't get prey type. We have no clue what they're running after. We could identify success. We could identify sometimes who made the kill. We did this over about 5 months, so some different seasons. What we didn't ever manage to do is over different populations, which is obviously key. This is just to show you quickly what the data actually look like. So this is what you extract. 116 videos. I seem to choose topics that require a lot of them looking back over data and watching it for hours. This is where the 6 dogs move, and what you then needed to do was try and identify whether it was successful or not, based on do the dogs gather at a spot, like here, for at least 5 minutes after they've all run at it. That's probably successful, they're feeding. Now they can eat an entire impala in 10 minutes, a pack of dogs. They don't hang around. That was what we managed to extract. Probably one of the most detailed data sets, and still one of the most detailed data sets of wild dog hunting. From the collars, we identified 1,119 individual chases, so that's when they're going at what we consider to be high speed. 116 of those were identified as successful, which is by me going through the videos, and that's roughly 1.16 kills a day. That's what we know from other studies is really typical of an African wild dog, so we're pretty happy with that. Their maximum speed, 42.5 miles an hour. Again, kind of equals what we know from other studies, so great. What was new was that the mean chase distance was 445 metres roughly. That's a lot less than people often think African wild dogs chase. They're often known as endurance hunters, thought to chase things really long distances to tire it out. We didn't see any of that. We saw lots of very short bursts of speed. Maybe getting something, if not going and trying something else. So not these big long chases which you often see portrayed in media. On average, 5.5 multi-dog chases occurred every day, but the multi-dog chases were just when one dog was going really fast and the others were kind of running. They weren't going as fast as that, they weren't all chasing at the same time. And in fact, only 35% of the time were they actually running at the same time in the same space. So they're not doing much of that at all. What we found was that they appear to be opportunists rather than specialists. When they see a good herd of prey, they will all have a go. And the chances of them making multiple kills increases. And that's what we saw. If there were multiple ones having a go, they would make more kills and be more successful. But it wasn't because they were working together. There was no sign of that collaborative process happening. We did see a slight, and we're talking slight here, fanning out before they would start a chase. So spreading themselves out. But of course you do that, because you're not going to want to run on top of each other. Sometimes it's actually just logic. I'm just going to show a video here. Now, the main thing I want you to look at in this video, again, excuses for the quality, is the environment. This is typical environment for African wild dogs. It's called Mapani woodland, and it is woodland. It's not open grass plains. That's the grass. I now focus on the grass. You can really see the grass. That's the dry season. And you're just looking at the vehicles not moving. There's my videos. I was trying to 1707. You can't see a thing. But it was the environment that I want you to look at there. Because that's incredibly different to where a lot of these studies have been carried out before. As I've said, previous studies were open grassland, where all the dogs can see each other, which is key, and they can see the prey. Here, the dogs can't necessarily see each other. The prey can't see the dogs. It's a very different environment. Also, in Botswana, the predominant prey are impala. Now, one African wild dog can pull down an impala. They don't need multiple of them, so why would they waste their time having multiple of them pulling down one impala? In the open plains, they tend to have much larger prey. There are more wildebeest and bigger prey, so they might need multiple dogs to be able to pull the prey down. And what's really important here is actually that the environment in Botswana is the environment where most of them are left. So this is really important to understand what they're doing there, thinking about the impacts now of climate change on this species, which is having a big impact in terms of the timing in which they can hunt, the heat of the day, and how that's balancing off as well. Because, quite frankly, African wild dogs are at the bottom of the pecking order. The lions will kill them. They tend to avoid cheetah and leopards. So they're right at the bottom of that pecking order. And what's really important here, though, is to bear in mind, just because they don't do it also doesn't mean they can't do it. And I cannot express how annoying it is sometimes when a species gets labelled as doing a certain behaviour. It's not a species that does a behaviour. It might be a particular population or group in a particular environment that can do that behaviour. That doesn't mean that others can't do it. They just might not need to do it. And I think that's something that's really important to bear in mind. I am really done. Very aware why it is now called me. Last two slides. Okay. Now skipping back to what I do today is collaboration in African wild dogs. No, they don't do it. I do it though. So I take on the idea forward, and I really think that collaboration is one of the essential skills that we can leverage in this rapidly evolving educational landscape. We need to work together. And what I love is that I've done so much recently with students as co-creators. Hello Beth, I'm going to embarrass you. To build actual teaching content, to build modules. We did some for the new Environmental Change and Sustainability programme. We've got professional services involved teaching on modules to look at the university as a living lab. We should be working together and using the knowledge from across all these really interesting spaces. Academics from other institutions, obviously from other disciplines. But I'm also now looking more at involving stakeholders from teachers right the way through to employers, because we're not an isolated landscape in the middle. We need to know what we're coming from and what we're aiming to get to, so that we can actually make sure that the education flows through it all. I've heard old Joe. Right. Adaptability. So all this does sort of make sense, and that we bring it together in terms of how animals, including humans, are adapted to their environment and their ability to cope with the changes, and particularly the changes that are happening so rapidly now due to climate change, is a connecting thread of kind of everything I've always done. Education will be key to cultivating the agile, interdisciplinary, problem-solving skills and innovation that are needed to address those challenges. And collaboration, I feel, is going to be key to empowering us to tackle those issues to create a more sustainable future. I'm going to leave it there. I won't talk about what next. Ask me about what next. Who knows? what I just wanted to say thank you to. Don't go hunting for your faces. Quite a lot of people have really out-of-date photos, by the way, online, that are really grainy and annoying. Some people don't have any at all, which means I couldn't find you. But none of this would happen without any of you in the room, any of the people up there, and that's what makes it fun, and that's what makes it enjoyable. So collaboration is the way forward. Thank you. I'm sorry, it's 2 minutes past 5. That's terrible.
Well, I mean, I think none of us will complain. That was an absolutely tremendous lecture, so thank you, Julia. My name's Rob Jackson, and I'm the head of School of Biosciences. It's been a great pleasure to work with Julia. I arrived here 4 years ago. She's been one of the best colleagues I've worked with in my career, actually. And so with that note, it's a real great honour to have this opportunity to thank her for her lecture. Of course, this is an inaugural lecture, and it's a very special occasion, of course, for her and all of us in this room. But it's also special because it's our opportunity to inaugurate the tenure of her professorship. And that's, of course, more than just a beginning. It's actually the opportunity to make this tenure auspicious, so particularly important going forward, to make it significant in the future, and to ensure that its good fortune is ensured. And of course, we've all helped, as she said here, in that journey. Many of us have that opportunity to help support Julia going forward. Now, what I particularly liked around the talk here today was the keywords that she used, because what she was doing was pulling out a lot of her career kind of work and experiences in those words. But actually, I was reflecting on those words in terms of Julia herself as a person, as a colleague. And the 4 ones I wanted to start with was openness, flexibility, collaboration, adaptation. And one of the things around those words is that actually we would know her for those qualities, and I particularly know her because of her leadership qualities. So Julia has come up through our system since 2012 to become one of our great leaders in this university, and those traits there that I've talked about absolutely shine in Julia. And one of those things that she's had to kind of use them to great effect for, first of all, as head of education in the School of Biosciences, is probably one of the toughest jobs in the university. You have to keep a lot of students very happy and engaged and make sure that they have a great time, but also you've got quite a lot of grumpy colleagues who also keep happy and make sure everything goes well. And so those qualities are really important for that particular job. There are 2 other traits I thought, though, that I thought I'd just pull out that I think also apply here. And one is resilience. And Julia has really shown great resilience. I mean, Indonesia sounded amazing, but we were in the bar one night. In the bar, she was telling me, I didn't realise that she was there for a year. But within 2 weeks, was like, oh my goodness, what am I doing here? And to have that kind of instinct at that point is, quite telling, really. You can have it's a make or break moment. The fact that she stuck it out for 12 months is due to resilience. So I think that's absolutely amazing that you were able to do that. And you've shown that going through your career in other ways, through the BASN, kind of debating, and obviously the dodgy videos that you've shown.
Not my skill.
But that resilience is important also in those job roles I mentioned, and particularly in the Director of Sustainability Education. It's a completely new role. And to start from scratch doing a role like that requires grit and determination and resilience. And so she's been making great headway in that particular role. The other trait I would like to mention is collegial. And all right, 266,000 data points. Could have got a few people to help you maybe, but no, that's a lot. But it's that collegial nature that we see with Julia started out many years ago back, I think, when she talked about those two colleagues who, they showed her a way in terms of thinking around philosophy and how to collaborate together to kind of get the best out of things, but also through to our brilliant colleagues, Susannah and Jackie. And they worked together as great colleagues over many years, and that's created great opportunities for them in their research. So it's amazing to see how that collegiality has really kind of shaped a lot of what she does, just for not only for herself, but also for ourselves. We're very lucky to have Julia in our school and in our university because of the nature of her collegiality towards all of us. And of course, the most collegial point in all of this is when we get her in the bar. It's not very hard. So it just goes to show it. So that's kind of validated. So, Julia, I just wanted to thank you again for your inaugural lecture on the power of collaboration. I think that the large photos there tells it all. It is a great opportunity for us to see what you've been doing. We've learned many things about your research, your education, now in the life of sustainability. And on behalf of us all, I'd like to thank you for that lecture. We're really looking forward to your continued tenure and to your success in the future. And we really hope that it may be attended by every good fortune going forward. Thank you, Professor Julia Myatt.